Exam 13 is tomorrow. Exam 13 going to be exam 12 plus everything we did last few days. Next 20 minutes or 30 minutes, I'm going to go over everything we did last few days. Okay, I'm going to give you a summary of everything we did last few days, and this problem going to be in the test tomorrow. So please make sure that what we do next 20 minutes, you understand everything. I'm sorry I don't have a mic with me, so I forgot it at home, so I'm not sure that the sound quality is good enough, but regardless, I'm going to give it a try. Let's start our, so what is the topic? Topic is electric force and electric field, and what better than thinking of a hydrogen atom to understand the electric force and electric field. Let's dive into hydrogen atom. Let's cut the board in half. Let's write the hydrogen atom. One proton, well, what do you call it, no neutron. We're going to draw the Bohr model for hydrogen atom. Okay, you have a proton and electron. In the future, you're going to learn that there is no specific location for electron. What does that mean? This electron is r distance away. What is r? I think 5.3 times 10 raised to -11. This is the average distance, right? Okay. There is no, like, you go there, you find electron. There is an electron cloud. It changes the distance. Sometimes it's here, sometimes here. Okay, all right, get it. However, average radius is 5.3 times 10 raised to -11. Good. We're going to try to find the force at electron. The force at electron will be what? Let's draw it. The force on electron due to proton is going to be like this. This is the force on electron due to proton. Now we're going to draw field. You know the field is just from positive and goes to the negative, right? You know that. Good. These are not force, these are field. Do not get confused between force and field. We're going to draw a field. Where are we going to draw a field? Let's see. The field starts from positive, right, and goes to negative. I'm going to give it a try again. Can I move? No, I cannot. So I have to try again. I will change the color. And we change the color again. Hopefully you will be able to figure out which one now we are trying to find. Is this the green one, blue one, or the violet one? Of course the violet one, because I asked you to find the electric field r distance away, 5.3 times 10 raised to -11. Is this 5.3 times 10 raised to 11, 10 raised to -11 meter away? No, this is 0 meter away from the nucleus. Is this 5.3 times 10 raised to -11 meter away? No. Is this exactly 5.3 times 10 raised to -11 meter away? It is. So we are finding that one, not these two. Good. So this is we're going to call field. Okay. We're going to find this one. The size of this two. How can we find the size of this two? Okay, that's very easy. F is equal to K Q1 Q2 over R squared. 9 times 10 raised to 9. Okay. 1.6 times 10 raised to -19. Negative 1.6 times 10 raised to -19. Divided by 5.3 times 10 raised to -11 squared. And that gives you -8.2 times 10 raised to Newton. Okay, good. Our math agree with our geometry. Our algebra agree with our geometry. Now we can find now the electric field. Electric field is, of course, F over Q, small q. We're going to call this one a small q, although the magnitude of the charge would be the same. But we're going to call, to solve our purpose, we're going to call that one a small q. So F is equal to negative 8.2 times 10 raised to 10 raised to, this is negative 8. Okay. Is it negative 8? Yeah, that's negative 8. Negative 8 divided by q is 1.6 times 10 raised to negative 19. Be careful with the sign. Is this cancel? 8.2 divided by 1.6. That's 5.1. So you can call this one 5.1 times 10 raised to. You have a negative 8 and positive 19. So it's going to be 11. And that is a Newton over Coulomb. You can do also this way if you don't understand this one. K big Q over R square, and that's 9 times 10 raised to 9. Big Q is 1.6 times 10 raised to negative 19, and R is what? 5.3 times 10 raised to negative 11 square, and that gives you 5.1 times 10 raised to 11 Newton Coulomb. Okay. So last problem, we talk about electric force and electric field. This problem, we're going to make electric field a little bit interesting. How? Let's create a right angle triangle. Okay. Let's make this one 30 degree. This one 60 degree. So this one must be square root of 3. This one must be 2. And this one must be 1 meter. Let's say this is Q2, which is 3 nanocoulomb. This is Q1, which is negative 4 nanocoulomb. Let's put a point over here, call it A. At A, we have two things. We have E1, and E1 gonna look like this. And we have E2, and we have E. Okay, so let's find the E. To find the E first, we have to find the E1. Okay, let's find the E1. To find the E1, you're going to have to write K Q1 over I squared. K is 9 times 10 raised to 9. Q1 is 4 times 10 raised to negative 9. And the distance is 4. 2 squared is 4. 4 cancel. This is just 9 Newton over Coulomb. Now let's find E2. E2 is equal to K Q2 over R squared. What does that mean? 9 times 10 raised to 9 times Q2. What is Q2? 3 times 10 raised to minus 9 divided by square root of 3 squared. So 3 cancel. So you have 9 Newton Coulomb. Okay. E1, E2, we found it. Now we're going to find the E 3 different ways. Okay, here is the first way. One way is R squared is equal to A squared plus B squared plus 2AB cosine theta. We're going to call it law of parallelogram. Okay, all right, so what does that mean? E squared is equal to E1 squared plus E2 squared plus 2E1 E2 cosine theta. Okay, please understand very carefully the theta. E is equal to E1 9 squared plus 9 squared plus 2 9 cosine. Let's find the angle. The parallelogram use angle between two vectors. Okay, vector 1, vector 2, angle between these two vectors. Let's find out angle between these two vectors in slow motion. Let's make it x-axis. This must be 60, this must be 90. Okay, if that's the case, then draw this one, bring it over here, draw this one, bring it over here. So this angle must be 150. If angle between these two vectors 150, you just write 150. Okay, so E is, then I'm gonna try to solve it. 9 square plus 9 square plus 2 times 9 times 9 cosine 150, and that's 4.7. E is 4.7 Newton over Coulomb. Okay, now let's say law of cosine. Okay, law of cosine is C squared is equal to A squared plus B squared minus 2AB cosine C, which is E squared is equal to E1 squared plus E2 squared minus 2E1 E2 cosine C. And this is angle between head and tail. Okay, forget that. E squared is equal to 9 squared plus 9 squared minus 2, 9, 9. Let's try to understand head and tail. Okay, let's draw this vector E1. Let's draw the vector E2. E2. Now, let's put the E1 on the head of E2. Okay, good. So E1, this is, what is E1? E1, E2. Okay, let's take E2 and put the E1 on the head of E2. Okay, if that's the case, then what is the angle? Okay, finish the parallelogram, then it's going to be obvious. Okay, this one we already know, 150. If this one 150, this one has no choice but 30. So cosine 30. So the E has to be nothing but 4.7. If you don't understand this one, then okay, don't lose hope. You're going to drive E is equal to E1, E2, E1x, E1y, E2x, E2y. 9 cosine 60. 9 sine 60. 9 cosine 90. 9 sine. So this one is 9, this one is 0. 9 cosine 60. 4.5. 9 sine 60. 7.8. Okay, now who is who? Let's call this one, forget about everything. Call this one E1. So what is E1x? E1x is 4.5. E1x. What is the E1y? 7.8. What is the E2x? Doesn't exist. What is the E2y? 9. So E2y minus E1y is equal to 1.2, and that is this. And then EX is equal to 4.5. So 4.5, 1.2. Okay? So you use the parallelogram, and what do you get? You get c squared is equal to a squared plus b squared. So c is equal to 1.2 squared plus 4.5 squared. And without using calculator, I'm just going to copy and paste 4.7 because it should be 4.7. Okay, so this is pretty much it. You are responsible for, oh, one more thing. You are responsible for tomorrow. And that is, let's say this. Okay, cut the board in half. Okay, let's say this is Q1, this is Q2. Let's say this is 5 microcoulomb, this is 7 microcoulomb. Alright. Let's say this is region 1, this is region 2, this is region 3. At what region Q3 will experience equilibrium? Q3 will not experience equilibrium at location 1. Why is that? If you put Q3 over here, then F1, F31 would look like, F31 would look like this. F32 would look like this. So this will accelerate this way. And Q3, if you put it over here, is not going to experience equilibrium. Why is that? For the same reason. This is F32 and this is F31. So it's going to accelerate this way and it's not going to experience equilibrium. If you put it in the middle, that's not going to experience equilibrium. Why is that? Because these are not equal in magnitude, like hydrogen atom. You have to put it closer to 5n so that it's closer to 5n is going to experience equilibrium. I'm going to put a point. In this point, what do you want to write? The force on 3 by 2 and the force on 3 by 1. So you bring this dot and you find the distance r. Q1 to Q3 is, let's say, 1 meter. You want to call F is equal to 0. So F31 is equal to F32. So K, Q1, Q3 is over R squared is equal to K. Q2, Q3 over R squared. K cancel. Q3 cancel. Q1 is 5 over X squared. Call it X. 7 over 1 minus X squared. The square root of everything. So the square root of 5 over X is equal to the square root of 7 over 1 minus X. X root 7 is equal to root 5 minus X root 5. X root 7 plus X root 5 is equal to root 5. Root 7 plus root 5 is equal to root 5. X is equal to root 5, root 7 plus root 5. And this is equal to 0.46 or something. So the distance between Q1 and Q3 is 0.46. And the distance between Q3 to Q2 is 1 minus 4.46. Another problem I probably going to give you is this one. So on Q1 is equal to, let's say, minus 8 microcoulomb. Q2 is equal to 3 microcoulomb, and let's say this is 0.3 meter. And let's say Q3 is 4 microcoulomb, negative 4. And let's say this is 0.2 meter. And let's find the force acting at Q3. So what is F31? F31 is this one. What is F32? F32 is this one. F32 would be bigger because it's closer. Okay, alright, let's find F31. F31 is equal to K, Q3, Q1 over R squared. So K is 9 times 10 raised to 9. Q3 is 4 times 10 raised to negative 6. Q1 is 8 times 10 raised to negative 6. Divided by 0.5 square. So this is 1.2. F32 is equal to K Q3 Q2 over R square. So 9 times 10 raised to 9. Q3 4 times 10 raised to negative 6. 3 times 10 raised to negative 6 divided by 0.2 square. So this is 2.7. Okay, so we're gonna write F is equal to F31 plus F32. F31 is positive because it's to the east. F32 is negative because it's to the west. So F must be negative 1.5 Newton. Okay, that's pretty much it. So exam number 12 and what we discussed today, last 20 minutes. I'll see you tomorrow. Good luck with the test number 13.